Alright, hey guys, this is the final video of the complex numbers series. This is for all of you who finished and you're still looking for something else to do. Justin, this is you. So we're going to look at functions of the form f of z equals z squared plus c, where c is a complex number in the form a plus bi. Okay, so this is called fractal generation. If you take a value starting, so let's start with 0, so 0 would be at the origin. You plug it in for 0, or for z, set c to I, and then whatever output you get, you're going to take that and put it back into the function. You get an output, then you take that and you put it back into the function. You get an output, take that, put it back into the function. And so what you're doing is you're making the sequence of complex numbers, and when you graph this on the complex number plane, the sequence looks like a fractal. If you don't know what that is, it's in nature, it's any shape or pattern that repeats itself, like a shell. Okay, it's a curve that's repeating its curvature until it gets smaller and smaller and smaller and smaller and smaller, and you can zoom into this spot here, and this curve repeats into infinity. So as far as you can zoom, that curve appears the same, so it will have this general shape no matter what zoom level you go into. Okay, so let's try this with what I was saying, using 0 for z. So I'm going to use the function here, so f of z equals z squared plus c. I'm going to use z equals 0 as the first input. And c in this case, so use c equals I. So let's use this. So we have f of 0 equals 0 squared plus I. Well, 0 squared is just I, so, I'm sorry, 0 squared is 0. I just have my I left over. So f of 0 is equal to I. This is now going to be my new input. So step 2, this is my new input. So f of I. So I'm going to put I in the place of z. And when I compute this, I squared is -1 plus I. So this is now my new input. I'm going to put in f of -1 plus I into the function. -1 plus I squared plus I. -1 plus I, so let's expand this out. So -1 times -1 is 1. Minus I plus I, so those go away, plus I squared plus I. 1 plus -I. Okay, so that's going to be 1 plus -1 plus I, which equals I. Did I do that right? No, I did not do that right. I'm sorry, I forgot something here. Let's go back to this step here. -1 times -1 is 1. -1 times I is minus I. 1 times -1 is minus I. That's where I went wrong. Plus I squared. Plus the I on the outside. Now we're talking. Okay, so -I minus I, that's going to be minus 2I plus I squared, which I'll turn into -1 plus I. So the 1's go away. So now I have -2I plus I which equals negative I. So then this would become our new input. Okay, so let me show you what this looks like if we were to graph it. Okay, so the first input is 0. The output is I. So I can graph that on the complex number plane. So think of 0, that's your input, think of that as your x value, and the output, the I, that's going to be like your output value. So I have 0, and then negative 1 appears here. Alright, so now, I am incorrect in saying this. So we have 3 different things going on here. I have an input, and then I have an output. The input is a complex number. The output is also a complex number. So being able to graph these on a single plane here is me saying that's possible is false. It's more like sort of like a 3-dimensional thing. So I'm putting in a 2-dimensional thing, I'm getting out a 2-dimensional thing. To be able to say, oh, one's the input, one's the output, like an x and y value, that's only accounting for one of those 2-dimensional objects. So like one input. So what people do is actually they graph the inputs. So we'll start with 0. The output, the I, what they can do is actually they kind of color code it. So they color code it. Okay. So now the new input is negative 1 plus I. So I'm going to find that here. Negative 1 plus I, that appears here. And then the new output would be negative I. So I'm going to graph that. And again, that's color coded. So you see how this is working? So then the new input, negative I, so I'll graph that. This then would also have a new output. So I'd graph the output with a color. And I'm going to post something on the Google Classroom that shows you what happens when you repeat this sequence infinitely many times, using the complex number plane to plot your inputs, and then using a color scheme to plot your outputs. It's called the Mandelbrot set, and it's really impressive. So I will stop this video. You can try number 72, and yeah, try number 72, and I'll post that up there as well. Alright. Well, let me just write it here. Number 72. The fractal, and they show a fractal. Actually, I'm going to have to put the picture because I'm not going to draw this. Alright, I will see you later. Bye.